All right, cool. So, I'll be sharing my a slide with you, and basically, last week we started the whole thing around mobile development, and I said something. So, but today I will share a slide rather, and I will be speaking through the slide. Basically, I'll be talking about the three forms of mobile development, although we had other forms to write, but I'll just speak about the popular ones and probably in the course of the other development, at least I'll be speaking on things that I know by the time you gather about 10 mobile developers, give or take seven of them will be around what I'll be talking about. So I don't want to bore you with other areas of mobile development, probably the like of Xamarin, Cordova. To a greater extent, most organizations I know currently, you are either developing with Kotlin, which is native Android development, or you're developing with Swift, which is native iOS development, or you're developing with a cross-platform mobile development framework such as React Native or Flutter. I don't write Flutter right, but I do write React Native. So I'll be speaking basically on I have some level of experience with Kotlin, I have some level of experience with Swift, and I have most of my experience with React Native mobile development. So I'll be speaking from those three perspective of mobile development. So my slide there, if you can see my slide, what I have here is cross-platform mobile development, mastering Kotlin, Swift, and React Native. So believe basically when it comes to mobile development, the word cross-platform basically means something that allows a developer to develop for multiple platforms using a single code base. So one of the reasons for this is because I'll give an instance. Say for instance, you have you have two mobile teams. Probably it seems that are developing for your Android. You have another team that is developing for your iOS. There is a very great chance, most times than not accurate. What happens is that your iOS may be behind your iOS team, may be behind your Android team, or your Android team behind your team when it comes to the time of completion of the project. I think I remember vividly when Channels was about bringing out their mobile app. It's a long time ago. I still remember very well that I remember that I think their Android application came out before their iOS application. So at the point where their iOS application came out, they had to re-advertise that we now have a mobile app on iOS on the Play Store. So when you have different teams, most times, I'm just giving you some of the reasons. When you have different teams, you have a separate team for your Android development, you have a separate team for your iOS development. There is a chance that one, the Android team might be ahead of the iOS team, or the iOS team might be ahead of the Android team. So in a case like that, you tend to have to go to store multiple times. But when you work with a cross-platform development framework such as React Native, with a single code base, you just need one team. When you have that one team and that one team has completed the work satisfactorily, you can go to store, either App Store for iOS or Play Store for Android. You can go to store with that single code base that single team have actually developed. So in other words, what I mean by that is that it saves time, it saves costs, and it saves the resources that will be needed to have two teams. So now, when you do cross-platform mobile development, I'll be speaking on the three eventually. When you do cross-platform mobile development, you have one single team developing one code base now, and that one code base can now be shipped to both Android platform as well as iOS platform. That's for cross-platform mobile development. Now, come to native. When you say native, native means something that is unique to a particular consideration. So when you say native mobile development in this field of mobile development, what you mean or what you are implying by that is that you are developing with something that is unique, customized, so to say, for a particular operating system. So, say for instance, Android, when you build mobile application in native Android, what you're doing is that mobile that you have built natively for Android only runs on Android and is unable to run on iOS. In contrast to cross-platform, where one single code base can compile down to Android and at the same time compile down to iOS. So in Android development, native Android, basically what you use is you use Kotlin. Kotlin is the language to use. And you use Android as the key. So I'll still come back to talk about Kotlin, but that is for native Android development. For iOS, on the other hand, what you have is Swift. And the framework basically is you're using either UI kit or you're using Swift UI. You have the two. And for the languages, either you're using Swift for native or you're using Objective-C. At least then Objective-C was used. There are still some legacy codes that still uses Objective-C. But as it is right now, I think from 2004, 2014, yeah, I guess, that was when Apple actually introduced Swift. And when changes like that happen, basically what's going to happen is that the ecosystem of that particular development will shift, just like Android, for instance. Initially, native Android was written in Java, but immediately Google, as the case may be, I think it's Google, right? Immediately Google came on board, and Google, in partnership with IntelliJ, declared that going forward, Android development is going to be Kotlin first. Yes, there were legacy code rather, that is code that had been written before that time, that were written in Java. Some of them will be changed, some of them may not be changed. So that's why when you come into some code, you see some languages that have not been, like, you're not told this language existed. No, they've been there. They were legacy code. So they are codes that have been written way back. When you come there, you maintain them. You improve them as well, right? But basically, most times are not. Developers don't improve them. Just maintain them and make sure that things don't break. So for native iOS development, initially it was Objective-C, but now it is Swift first. That's native iOS development. I don't know. Thus far, does anybody have any question before I move on? Okay. If you have a question, please raise up. Just signify by raise of hand. Set. Or better stay. If you have any confusion, any question, just try as much as possible to pen it down. Then when we'll come back to it and we deal it. So now, for cross-platform development, please pardon me, most of my slide will center around cross-platform because looking at the market space, you will see job for Android and iOS, but in most cases are not. They need a senior engineer. Most cases are not. Aside that, a good number of companies are actually looking at and sees resources. So you don't need to hire so many engineers for different things. You just hire one team, just one team. That one team can ship to Android, can ship to iOS as well. So with that, you have reduced cost for staffing and for human power. So now at the same time, you have a single code base that can be shipped every time, and you can make changes both on Android and iOS at the same time. So For cross-platform, you have React Native, and React Native is the popular framework for building mobile application. It basically uses JavaScript, although nowadays, most times you tend to write with TypeScript, but TypeScript is also JavaScript. Those are programming languages now. TypeScript is also JavaScript. But the difference basically is that TypeScript is JavaScript plus a language. Sorry, TypeScript is JavaScript plus types. That's the word. Sorry for that. Plus a language. TypeScript, let me take it again, is JavaScript plus types. It's more like, um, excuse me, it's more like saying something like, um, jollof rice is white rice plus two already from the get go. Or you say something like sandwich is bread and egg. So sandwich is still bread, but it's bread and something else. I don't know. Maybe it's bread and egg. I wouldn't know. So TypeScript is actually JavaScript. So everything you do in JavaScript, you can do it with TypeScript. But now because you have types, you can now do both what you can do in JavaScript as well as things you cannot do in JavaScript. So nowadays, most application, when you come on board on most application, you tend to see TypeScript. In fact, virtually everybody that writes JavaScript nowadays or that writes something that has to do with Node, or yeah, virtually, if not all, tend to write JavaScript. And it has its own benefit, right? Some other benefit, which we get to talk about. But just bear that in mind and hold that with you as we navigate through the course. So it basically what React Native does is it allows developers to create native apps for both Android and iOS platforms. So it allows you can create with just one single base. You don't need code bases. One single code base. You can compile data from sorry, with just one single code base, you can compile your code to both Android and iOS. So other things you need for React Native is you need a knowledge of React, like the React hooks. You need the knowledge of the states. You need the knowledge of the nuances around React, the different libraries. I mean, the different packages. You need an idea of everything. At least a good React, the context, API, as well as some other things. And the idea of that will actually enable you to be able to create applications that can compile both on Android and iOS. And yeah, then another thing is that about sorry, I've mentioned this. So another thing, advantage of this cross-platform development is that you can update easily. When you update from one single code base, once you make an update, the updates get triggered on both Android and iOS applications or iOS devices. Sorry, but unlike somewhere where you have two teams, you have a team for Android, you have a team for iOS. When you want to make update, you have to make the update differently. And in case like that, the operate update rather will form. You have different updates at different time. So that's the way it is. So now the way it is that having it expose you to both Kotlin and Swift, although I will still give an in-depth thing about each of them and the career path, the pathway, the roadmap for each of them, as well as React Native. So it lies on you that anytime you want to build an application, one, to build Android separately and iOS native. But a good number of banks in Nigeria, for instance, their startups, their all of these guys, most times they tend to use React Native because one, updates top notch, you can update at any development, deployment, you can deploy to any platform at per time. So it's something that you can change things across, you can send notifications from just one single code base to both Android and iOS. And yeah, it requires basically is preferred for projects that requires rapid development across platforms. Probably a startup, for instance, comes up to you and say, "Oh, we want to build a startup." Maybe it's a startup of like 5 members, and they're saying, "We want to build a mobile application." It will be wrong for you to tell them that they should have an iOS team separate. You should have a Kotlin, an Android team separate. No, that's not professional. Basically, because this is a startup, having two teams separately is going to increase cost for them. They will have to pay more. They have to pay two different engineers. They have to, you know, see the way to manage two different engineers and to keep them at the same pace. What might not happen. But if you have just one single code base that everybody making contribution in this conversation, I mean React Native, everybody is making contribution to. What happen is there will be rapid development across the platform. You can send notification anytime. It's gonna be a moment where you can make update anytime. Nowadays you have push notifications, you have excuse me, you have automated download that something like it checks your phone and it prompts you to download. So you can do all of those easily if you are on a cross-platform development, a cross-platform using a cross-platform framework. So now it says in conclusion, mastering Kotlin Swift and React to equip developers with the skill to excel in cross-platform development. So as technology evolves, staying updated on emerging trends. All of these guys still have emerging trend. There are things that are happening in Swift, uh, tools that will be useful for maintaining competitive edge in the mobile development landscape. Thank you. So having said this, before I go straight, now I'll be going to both, I'll be taking them separately and be talking about their career, like the roadmap to go junior in each of these or an entry level person in each of these, and to go from being entry level to being a senior mobile application developer. But before I go into each of them, I would love to take one or two questions, responses, as well as your participation. So,
Good evening, sir. Hello, can you hear me, sir?
yes, I can hear you. You can speak on now.
Yes, sir. Thank you so much for this wonderful class and opportunity, sir. I so much appreciate, sir. Yes, sir. My question is this. Sorry, for website development, I know they have front end and then back end. So I just want to know for mobile app development, is there still something like that front end and back end? Like example for this cross-platform development, is React Native, does it cover, is it enough to develop an app, or is there still something like front end and then back end in mobile app development? And then secondly, sorry, for this React Native now for mobile app development, do I still need to go and learn HTML and CSS for me to be able to develop an app, or is React Native enough for me to develop a cross-platform app? Thank you, sir.
But I'll be now. Actually, I think I love your question. That was actually a very good question. So I'm going to go ahead and answer the question. The first question. Then the second question, I will give a little description of it. Then when I get to my slide on React Native, I'll do more justice to it. So for the first question, backend development. There's something about backend development. Most times, probably if that's something about API and the likes. So basically, what backend development does is it creates services, right? It creates services. Let me use the word services that the front end can make requests to. Then the front end now being the client, and you have the server in the back end. But the backend, the servers give back responses based off the request made from the front end. Now, mobile developments to a greater extent is actually front end. It's still front end. But now you're not developing for the web, you are developing for mobile applications. And you can do some things within mobile development that may want to seem like backend, may want to seem. For instance, take for instance, you could cache data. We could use something like probably Room database. We could use something like Room database, which is local to Android. When you do something like that, fine, you have a local base, you have a database that is local, right? But it's not remote, it's not online. Other persons cannot make requests to it. So it's basically for your mobile application. So to a greater extent, mobile application is still a front-end development, but now you are not developing for the web. Most times when the people say front-end development, they tend to refer to the web, right? But mobile development also front-end development is just front-end development. It's like an aspect of front-end development, so to say, that is for mobile devices. It's not for browsers, it's for mobile devices. So at the end of the day, the mobile devices, the app you're building for the mobile devices still has to communicate with a remote server. For instance, now let's say you built a login page. For instance, let me give you an instance. Um, some of us have used we've used app, say for instance, probably maybe a food ordering app. Give for instance Chowdeck. If you know Chowdeck, please can you indicate your hand if you know Chowdeck? You know the app Chowdeck. Just indicate the areas of one. Okay. If you don't know Chowdeck, if you have a bank and you use the mobile application of a bank, please can you just indicate by a raise of hand? It could be any bank, Access, GT, any bank. Can you indicate with a raise of hand? You have a mobile application you use. Anybody? I don't want to believe you don't have mobile applications. Okay, so now when you want to log into the mobile application, get you log in, you enter your probably your account number, right? And you enter your password, then you click login. When you click login, those details are sent a remote database. Where you are sending those details to is still the backend. So a backend, say for instance, a REST API backend can be used for a backend that is developed, right? When you develop a backend, most times they call it REST. So in the case, REST in the sense that, like REST API, REST in the sense that it's stateless. It's not about the device that is communicating with it or communicating to it. It's it gives the response based on the request, based off the request. So mobile, to wrap it up, mobile development is still a form of front-end development, but you are developing interfaces for user interfaces now for mobile application. I don't know if that's clear. If it's clear, you can just give a thumb up and you understand the response. All right, cool. Thank you. So for the second question talks about, do I need to learn HTML and CSS? To a greater extent, when you come to mobile development, you don't need HTML and CSS. To a greater extent, you will be learning the component. Mobile development has its own component. Yeah. When you come to Android, for instance, you'll be doing the likes of um, text view, relative layout. They have their own component, just like you have div, section, blah blah in web front end development. Mobile development will have their own components. So when you come to mobile development, more like you have to learn the component for mobile development and the props that are available within that component. So when you go to Swift, you have UI view, you have image view, you have button, they have their own components. So they are called components. right? So when you come to mobile development, you learn those components. So I can use those components to actually develop user interfaces. I don't know if that's clear. But one thing that will help you, if it's clear, you can just give a thumb up. One thing where you'll shine if you've had the experience in the web is that when you start styling, you can, to a greater extent, you'll be able to relate with the styling easily and you'll be able to find your way around. So, having said that, since you said that's clear, I'm just going to go ahead and share my second slide, which is so basically about Kotlin. Kotlin, that's for native Android development. So it's basically mastering Kotlin from junior to senior. So basically, Kotlin, when you say Kotlin, Kotlin um, is an object-oriented programming language. I mean, and it has it's it's a JVM language, just like if you have the likes of Scala, uh, but it runs when you want to run Kotlin to a greater extent. You are running it on a Java virtual machine. That's the way it works. So it's more like you need the Java environment to compile your code. Yeah, more like that. But the difference between Kotlin um, and Java is because to a greater extent, Kotlin is declarative, and there are some things that you do in Java that Kotlin can easily infer for you. And although right now Java to support some Lambda function and the likes, but there's a way you can write Kotlin. You can write as OOP, object-oriented programming, or you can write. I'll still explain that afterward. And um, you can write as functional. Yes, and Kotlin is actually a very simple language, so to say. Permit me to use it, and it's almost like English. Like it almost sounds like English. When you start writing, you start saying something like. So when you want to write, I told you there are different. There are three, more like different areas you can go into when you want to do mobile development. You have native Android, you have native iOS, and you can go cross-platform. So I'm doing the native Android right now, speaking about it. So when you want to learn native Android development, the first thing you want to learn is you want to learn the language. You know, most times some persons make the mistake. Probably they want to learn a framework. They don't understand the language that the framework speaks. It's just like, for instance, I'm coming to a place, right? I'm coming to a place. I want to do business in that place. I must understand the language of that place because basically what I'm trying to do is I'm trying to do IFing. I'm trying to do something like trying to when I don't understand the language, what I'm doing is I'm trying to jump before I walk. It's more like you have to walk, jump, and fly. You get so it's more like I'm trying to jump before I walk. Oh, anytime you want to learn anything, the way to go most times is one, understand the language upon which what you want to learn is built. Understand that language is very important. So when you want to do native Android development, the first thing is to understand the language. And the language in native iOS is native Android development is Kotlin. That's a programming language. You start with understanding the fundamentals in Kotlin, understanding what Kotlin is. I think Kotlin is named after an island. I think probably Russia also. I can't remember the place, but I know it's named after an island. Understand the language. Understand how do I declare a variable. Understand the differences when I declare a variable and a constant, understand the different data types, understand the different control structures, understand the way conditional runs, understand when it returns a reference, the difference between reference type and value type. Like these are the building block. When you understand this, they form your foundation. It's just like I don't know ABC and I want to write an essay. It's not gonna happen. Most of the applications you're building, they are gonna be like you're writing an essay. That's the way the applications you're building are. You're writing an essay. But rather, if you don't understand the building block, you don't understand the ABC, you find it very difficult to write an essay. Or at the end of the day, when you're writing the essay, just like somebody says, there's something called illiterate essay. So the essay is going to be like an illiterate essay. So your app that you're building is not, it's not going to be scalable. Your app that you're building is not going to make sense at the end of the day. So the first thing you want to do is understand the language. And the language for Kotlin is actually, for native Android development, is Kotlin. And the next thing you want to understand is you want to understand OOP. Why do you need to understand OOP? The reason is because Kotlin is an object-oriented programming. OOP means object-oriented program. When you hear OOP, anyway, on object-oriented programming. Now, what's the meaning of object-oriented programming? I'll just explain it to you. Everybody knows a car here, right? So a car is an object, right? A car is an object. Now, your car, usually any car, there are some things about any car. The car has features. The car is white. Those are features of the object car, right? The car has four tires, features. The car has silencer, features. So those are features, right? Now the car can do something. What can the car do? The car can, you can drive the car, you can park the car, you can reverse the car, you can use the car to carry loads. You can use the car to carry load. You can use, you get, those are things that you can, the car can do. The car can do that. Now bring it on. When you do object-oriented programming, what you're doing is you're programming like an object. The way an object is, you have fields. Those are features of whatever you're doing. We have functions. Functions are basically what you are doing can do. For instance, now there are things you call classes, object, and I'll mention some of them afterward. Now, in object-oriented programming, part of what you do is you write classes. Now, a class is like a blueprint. I'll give you an instance. Every car has a blueprint. There's a, for anything you will call a car, there's a blueprint. If something has three tires, you cannot call it a car. It's a tricycle. So every car is a there's a class of car, right? There's a class called car, and anything that will fit into that class must have four tires. If you have two tires, you cannot fit in. You're not a car. You are a bicycle. If you have three tires, you are not a car. You can't fit in. You are a tricycle. If you have four tires, yes, you're a car. If you have eight, you're no more a car. We can't call you a car again. Probably you could be a truck or trailer or something. So the class of a car, class is more like a blueprint that defines anything that is coming out of it, or anything that will fit into it. Is a blueprint. So now the class is the blueprint. Now, what's the way it is? The object is like anything that looks like that blueprint. I'm just trying to put it as simple as we can. That's not the real definition. Anything that looks like that blueprint. Say, for instance, a Toyota Corolla. That's an object. Does it fit into the class of a car? Yes. So it becomes an object of the class car. I don't know, maybe that's clear. Toyota Camry. Does it fit into the object of, does it fit into the class of a car? Yes. So it is object Toyota Camry fitting the class of a car. So the class is the blueprint. The object is the sample of that blueprint. And you have some things in object-oriented programming. You have encapsulation, you have polymorphism. Uh, Basically, these are features that you have. So you need an understanding of OOP before you continue. That's another thing. Then you need understanding of functional programming. You have lambdas, you have higher functions, you have higher order functions, you have pure functions, you have different functions. Now, basically, when you do functional programming is a way of write is a another way of writing programming where you are writing things that your app can do. That's basically one of the ways. When you write functional programming, it's different from classes. You're not writing classes now. You're not trying to bring in prototype and the likes. But in functional programming, you are writing your programs, you are writing everything as functions, as things that are happening, so to say, something happening. So you need an understanding of functional programming when you want to go into native Android development. Then when you want to go to my time is, I think I will just do this native iOS Android alone. Then probably next week we'll look at native iOS, then we'll look at React Native last. But when you want to go into native Android, having understood the concept, the language Kotlin, you understand functional programming, you understand object-oriented programming. The next thing is to understand the environment, understand Android SDK. You need to understand Android SDK. You need to understand the activities in Android. You have different activities in Android. Permit me to just Google the activities in Android so you get it. Activities in Android. So, Android activities. So, basically, these are just levels of interaction when your screen comes up. All are level, and you need to understand these things so that you can understand when things happen. So you have the activity life cycle. Basically, this you have on create when that's the first callback that is fired when your activities. For instance, now when you open an app, when you open any app, and probably you see a splash screen come up or something, that's what's happening is the first level, the first activity that happened, that's on create. So the next thing is application become visible to you. The first thing is that your application is created. Then on that, the next thing that happens is you have on start. That's where the activity becomes visible to the user. That's the next thing. Then the next thing that happens is you have on resume. Those are different callbacks. They are basically functions that are called. They are callbacks. So the first thing is before you start interacting, on resume take place. So probably you want to run some background thing in between on start and on resume. You understand those activities so you can run those background activities before on resume comes up. Because if you don't run them, probably you want to do some things, you want some things to happen before your users start interacting with your application. Probably you want to pick location, you want to pick the location of the application before the user starts interacting. Probably you want to pick the battery level. People want to pick up the Bluetooth, anything you want to pick up before the user start interacting. Then you have the on pause. That's when the activity loses focus and it goes to a pause state. Usually, probably you press something like a back button. So, or basically, sometimes you you let me give you may minimize the app and it's still on screen, right? But it's still on screen. If you minimize the app, for instance, you still see that it's still on screen until you wipe it. So the next thing is you have on stop. These are callbacks. These are different life cycle. When you do on stop basically happen in a case where the app is no longer visible to you. The application is no longer visible to you. Then when you click on apps that you have minimized and you click on that app again, you have on restart. So the app restart. That's why you notice that for some application that you don't have token live or you don't have token support or something. When you minimize the application, it will not start for some application. It will not start from the very first screen that you were. It will start again from the very beginning. So you need all this. You need intent, the knowledge of intent and filter. Then having understood that, you need the knowledge of asynchronous programming for and basically what this does is it helps you to manage background tasks. It helps you to basically what coroutine does is coroutine is more like you have different workers. Like instead of having a thread doing everything, I'll talk about thread later. You have different threads. Those are basically where you're more like pipelines where the activities run, right? So instead of having one thread where you will have every activity. If you have every activity running in one train, it's just like the refinery, for instance. At the point they were saying, oh, the refinery is not up to capacity, it can't produce up to this. So instead of having one thread where everything runs, you have different workers in the background that are carrying out the work, like small workers carrying out the work. You get? So then you need knowledge of dependency injection for testing, for your code maintainability. You need testing and debugging. You need the idea of testing, JUnit, Espresso, Mockito. You need like a knowledge of this to test. Then probably you build your portfolio. Basically, when you start building portfolio, you start building projects. You start working on projects. You start adding projects to your portfolio. Then you continue learning, and you keep learning. So if you have any question, I'm gonna stop here for Android, native Android. Then next week, I think next week we'll look at both native iOS as well as cross-platform for um, cross-platform using React Native. So if there are any question before I wrap it, I'll just take few one or two questions, then we can wrap it. So in the absence of any question, I'll just wrap up with this. I actually don't have that in my slide. Just in line with Obina question. So when you do native Android, you need to learn how to build UI. So initially, UI in native Android was built with XML, but nowadays you have Jetpack Compose. It's almost like, let me before give you the way Jetpack Compose is. It's almost like you're using React to build UI in front-end development for the web. So Jetpack Compose is actually more like a framework that has all the components you need to build user interfaces for native Android. So is either probably for legacy code or old code bases, you tend to see XML, you see the likes of text view, image view, button view, um, relative layout. We have some layouts as well. So you see all of those in Android development. So when you want to do the UI for Android development, the user interface is where your users get to interact with the application. You most times than not tend to work with Jetpack Compose to actually build out your UI. So in the absence of any question, I'm just gonna wrap it up here for the day and see you guys next week. Have a great day and have a great week.